Hello everyone. I hope you all are good and safe. Welcome again to the AIET question discussion session, and this is the very first uh, paper of your AIET for class 12. So I have selected, just like previous year, I have selected some basic basic important questions that I feel like you may be getting stuck. So let's navigate through those questions one by one. So this is the very first question and also the first question of your paper. This is a certain reason kind of question. So the first statement is a charge conducting a sphere will be able to retain charge for a longer time than a charged conducting cylinder. What is difference between a sphere and cylinder? Just of geometry varies, right? So cylinder is something like that, and a sphere is something like that. So if you look at these two structure, you can see that uh, for for the case of conducting a sphere, every point on this sphere has same curvature and same radius, that is r. But if you look at cylinder has some pointed regions. Then and the radius of curvature of those pointed regions will be very what small. Then and this straight line kind of region will have radius of curvature as very large, right? So basically, in their geometry, there is a difference of curvature, and how this curvature is going to affect for how long the charge will stay over there. So let's discuss that. For this, to solve this question, you need to have one thing in your mind, that is, when we are given, suppose we are given two spheres. One is of radius r1 and another sphere is of radius r2. Suppose this had charge q1 initially, this had charge q2. And now what we are doing is we are connecting them through a conducting wire. Now what will happen? If there is potential difference, like initially potential of this sphere is kq1 by r1 and its potential is kq2 by r2. Let's say this is v1, let's say this is v2. And if v1 is greater than v2, what will happen? Charge transfer will happen, right? So charge will get transferred from one sphere to second until both will share the same potential, right? So you can easily calculate what will be the ratio of final charge on these two spheres, right? So suppose finally this sphere had charge q1 dash and this one has final charges q2 dash, such that q1 dash plus q2 dash, definitely it will be equal to q1 plus q2, because charge is just getting distributed from one to another, is not leaving the system of these two spheres, right? So this is this, and also we can say kq1 dash by r1 will be equal to kq2 dash by r2. If you solve these two, what you will get? You will get q1 dash by q2 dash is equal to r2 by r1. Okay? It means what? It means if radius of curvature is larger, if r2 is larger, q1 dash will be smaller, because sorry, uh, here you see they share inversely proportional relation. So q1 dash is inversely proportional to 1 by r1. So if r1 is larger, q1 dash will be smaller. And if r1 is smaller, q1 dash will be larger. So if suppose I'm now telling you curvature of this uh, conducting surface is like this, so this portion has larger radius. This pointed end, here pointed end has radius equal to 0. And in that case, q1 dash will tend to infinity. It means here maximum charge will accumulate. Then, and you must have studied in your electrostat, there is one line given in NCERT also. If certain charge is getting accumulated in certain pointed region, it means what? Here the charge density, that is sigma, is very large. And if sigma is very large, you already know one more thing, that is if seat of charge having charge density sigma is given, then electric field in front of it is written as sigma by 2 epsilon naught. Okay? And so this, in this pointed region, if sigma is larger, electric field near this pointed region will also be larger. And if electric field is larger, then what may happen? Like this certain kind of a structure is kept in environment, right? Environment has what? Air. Air is what? Insulator. Why it is insulator? Because there is no free charges present. But just imagine there is an atom, and atom will have electron, and if electric field is very high near certain region, then that electric field will apply very large amount of electrostatic force on this electron of neutral atom, and it may pull that electron out. It means ionization may happen, and in that case, this AO will become conducting. And if AO becomes conducting, then what will happen? Like negative charges are there, positive charges are there. Negative charge will get attracted to this point, having higher density of positive charge, right? So this is going to lose positive charge gradually, and that is called your corona discharge. That is also called technically. So basically, it will start losing charge. So always, like when we are trying to store charge on certain conductor, it is advised that that particular conductor has no pointed ends, because if it has pointed end, that will attract most of charge on it. And if that is the case, around that pointed region, electric field will be higher. And in that case, dielectric, that is air, can break down, and then charge will start getting neutralized. Okay, that is loss of charge will happen. Now let's read the statement. So a charged conducting sphere will be able to retain charge for a longer time than a charged conducting cylinder charged to the same amount. Curvature, second statement, curvature is not uniform in the case of cylinder. Yes, because cylinder के पास जो curvature है ना, that is not uniform. It has some star points, right? And if it has some star points, loss of charge may happen. So statement 1 is true, statement 2 is true, and statement 2 seems like it is explaining statement 1. So correct option, we should go with what? Correct option should be A. Okay? Chalo. Now let's move on to the next question. A wooden block performs SHM on a frictionless surface with frequency mu naught. So there is a system, there is a spring attached, and then there is a wooden block kept like this. And this particular system is performing SHM with angular frequency F. So here, if you remember, omega will be equal to root under K by M. Okay? So angular frequency is defined as what? Omega is equal to 2 pi F. You can write it accordingly. Now let's read the question. The block carries a charge plus Q on its surface. Like before, okay, first let's read the question. If now a uniform electric field is switched on, as shown, then FHM of block will be. So in second case, what is happening? We are placing a charge plus Q on it, and then we are switching on electric field. Done. And then it is asked what will be what will be its mean position and what effect will happen to its frequency. Okay. So if you talk about frequency, how we calculate omega? We simply write force acting on the body. So case 1, when there was no charge, in that case, if you see, if we are displacing this by certain distance x, say, then what will happen? Displacement is in this direction. A spring will pull it in this direction. Then, so force will act opposite to the displacement like this. And force can be written as MA minus KX. A is equal to what? Minus K by MX. And this is our omega square, right? From the standard equation. Now, if we look at the second case, अगर आप second case की बात करो, तो what will happen? See, for calculating omega in SHM, what we do, we give that body first certain kind of displacement. जैसे कि यहाँ पे मैंने दिया. I displaced it by x and then I saw what force is acting. But here, suppose the system was like this, no disturbance. All of a sudden, what you did, you kept here plus Q charge. Again, nothing happened, but you switched on electric field in this direction. Now what will happen? This electric field will apply a force on this charge in this direction, because on positive charge, force acts in the direction of electric field. So the moment electric field will get switched on, what will happen? Force will act on this charge, which is kept on the block. So in totality, it will seem like force is getting acted on the block. So because of that force, again, you are not displacing it. It is happening because of the presence of external electric field. So what will happen? Electric force will act. How much amount of electric force? QE. And when this force will act, this block will move in this direction. Say it is moving by distance x naught. So if it has moved by distance x naught, after that it is getting stopped. Why it will get stopped? Because its electric force is QE, and this, because of this force, this block will move towards the spring. The spring will oppose its motion until a spring force will become equal to QE. So Kx naught. So when compression in the spring is QE by K naught, K, then what will happen? Then this system will come into rest. Now, when a spring has got compressed by distance x naught, there is a plus q charge, there is electric field in this region. Now electric field will not disturb it because q is getting balanced by k naught. Okay? Now at this position, if you displace this block by certain distance x, say, what will happen? Again, electric field will come into being because equilibrium position is, again, electric force is acting at this equilibrium position also, but that is getting balanced by kx now. When you are displacing it by distance x, what will happen? Again, that balance point will get disturbed and different scenario will arise. Let's write the common equation. Force acting on the body, you will write as what? Body having a block and charge. Okay, so minus kx plus minus kx force will act in this direction. Okay, and QE is also acting in that direction. So यहाँ पे मैं minus QE ऐसे लिखती हूँ. Okay, always remember in SHM, if you are writing the force equation, and in force equation, if there is a term, then जैसे in this force equation there is two terms. One is minus kx, another is q. So QE is basically constant term. It is not depending on x. This term is dependent on x. So always remember, when you are writing net force in such cases, and you are getting some constant term in the force, then that constant term will not affect angular frequency. So here also, if you have to calculate the angular frequency, you will only consider this equation, because this constant force will affect its equilibrium position, its mean position, not its frequency. Okay. So what will be the answer? Answer will be of the same frequency with shifted mean position. Yes. So mean position will shift by how much distance? QE by K towards the direction of electric field. Now, a spherical portion has been removed from a solid sphere having a charge distributed uniformly in its volume. So there is a solid sphere having uniform charge density, say rho. Now what is happening? From it, we are removing a cavity of this shape. Okay? Electric field inside the emptied space is. क्या हो? ठीक है? तो सबसे पहले let me tell you one thing that you all must be remembering that also. Recently, you must have studied, if there is a solid sphere, non-conducting solid sphere, and charge density inside is rho, then at any point x, electric field is written as rho x by 3 epsilon naught. If charge is positive, electric field will be outward. If charge is negative, it will be directed towards the center. Okay, so this is going to be your value. Remembering this value, we will solve this question. So let's solve it. Now suppose कर लो, what I did now, I removed a cavity from there. Done. And now inside cavity, I have to calculate electric field. So let's take a point inside the cavity. तो inside the cavity मैंने यहाँ पे एक point लिया. एक काम करती हूँ, cavity को थोड़ा बड़ा बनाती हूँ. Otherwise क्या है ना, देख नहीं पाओगे तुम लोग. So let me draw it a little more big. This is the center of cavity. Okay. Chalo. Now let's take a point, any point inside the cavity. So I have taken this. Now how we will calculate electric field inside the cavity? So electric field inside the cavity will be electric field because of whole sphere minus electric field because of charge in the cavity region. Done. So because initially when there is no cavity, there will be certain electric field at one point. Okay? And when we are removing the cavity, so to calculate electric field at point 1, what we can do one thing, electric field because of whole sphere minus electric field because of cavity region. Cavity region which was initially occupied by charge, right? So electric field because of a sphere at point 1 will be how much? तो चलो मैंने यहाँ पे इलेक्ट्रिक फील्ड आउटवर्ड लिया, पॉजिटिव चार्ज दिया है. So this is rho. चलो इसको मैं x1 बोलती हूँ, इस डिस्टेंस को. So it is rho x1 divided by 3 epsilon naught. ठीक है? And electric field at 1 because of cavity region will be how much? Cavity region which was initially filled with charge, it will be how much? Suppose this distance is x2. So minus rho, because charge inside the cavity, before it was cavity, was rho only. So rho x2 by 3 epsilon naught. So what you will see, rho by 3 epsilon naught, x1 minus x2. Okay? So rho is a constant, 3 epsilon naught is a constant. Let's see x1 minus x2 is what. So if you look at x1 minus x2, so this is x1 and x2 को minus कर रहे हो ना, so cavity region में भी positive charge था, electric field at 1 will be like this. But when you are giving minus sign, electric field will get reversed because we are subtracting it. Done. So its direction will be this. So this is x1, this is x2, and if I combine this, then x1 like x2 I said is, चलो मैं अच्छे से draw करती हूँ फिर से. You should not get confused. Okay. So this was the cavity point. This is x1, and this was your what? This was the center. Suppose this was x2. So minus x2 is what? Downward. Done. So x1 minus x2 का मतलब क्या होगा? Minus x2 ऐसा जाएगा, and this is. So x1 minus x2 is nothing but this line, and this line is what? Line joining the two centers. Center of whole sphere and center of cavity. So let's say this is T1, this is T1, T. So rho by 3 epsilon naught, T1, T. So T1, T2 is a constant vector, right? Distance between these two centers will remain constant. So whole this term is coming constant. Yani ki electric field inside cavity has a constant value, and also its direction is constant because T1, T2 has a direction of this. So inside cavity, electric field will be in the direction of C1, C2. So if I draw that for you again, this is a very important question. Keep this in your mind. So if this is the direction, C1, C2 direction is this. Okay? So electric field inside cavity will be parallel to this, like this. And that electric field will have constant value, rho by 3 epsilon naught, C1, C2. Okay? So correct option should be B, non-zero and uniform. Yes, it's uniform and it's non-zero. Chalo. Now Nitin is a very naughty boy. While in an elevator which is moving up with an acceleration of itna 6 meter per second squared. So acceleration of lift with respect to like nothing is given with respect to what, so it is with respect to ground, 6 meter per second squared. He throws chewed gum to make a stick at the ceiling, to make it a stick at the ceiling of the elevator. He throws the chewing gum with a speed of 8 meter per second with respect to lift. So speed of chewing gum with respect to your lift is how much? 8 meter per second. What should be the minimum height of elevator so that the evil plan doesn't get executed. So what should be the height? So with respect to lift, the height should be such that he's throwing, and if that gum is moving up, but before it touches that height, the speed of gum should become equal to 0. Then only gum will not be able to stick to the ceiling, right? So what should be our target to solve the question? To make its velocity 0 just before the uh, ceiling, right? So let's write equation with respect to left. So let's say height is what? Let's say height is h. Done. So v square equal to u square plus 2a formula we can use. Final speed we have to make it 0. Initial speed with respect to the lift is how much? 8. So this is 64 plus square. Now what is the acceleration of this gum with respect to lift? So acceleration of lift with respect to ground is given, right? And what is the acceleration of lift with respect to ground is given, right? And acceleration of gum with respect to ground is also given. It's not given, but it's known. Like if you are throwing a gum inside a lift, it will go up and gravitational force will act downward. So that will be equal to minus 10 meter per second square. So what will be the acceleration? This is ground. Okay. What will be the acceleration of gum with respect to lift? If you are going to break it, this will become AL minus AGR, and this will be AG minus AGR. So if we subtract, we need to calculate what? We need to calculate A acceleration of gum with respect to lift. So we need to subtract second equation with the first one. Okay. So if you are going to जैसे AG minus AGR, इसको माइनस करोगे किससे? AL minus AGR. Then you will get what? Then you will get AGL, and that is equal to how much? This minus this किया है ना हमने? So this is minus 10 minus 6, that is minus 16 meter per second square. So let's put the value here. Minus 2 into 16 into S. So 32S will be equal to 64 into okay, 64 into, okay, 64 ka square I have done, that mistake I have done here. This is 8 ka square, right? Sorry. So you write it, write 8 here, and that will become how much? 64. So S equal to how much? 2. So correct answer will be 2 meter. This is your correct answer. Write equation properly, like see with what respect you are writing. That is very important in this question. Now let's do this question. A charge Q is placed at a distance √3r from the center of a ring of radius r. The total flux passing through the length. So this is a charge. From here, electric field must be coming outward like this. Like this. So we are asked what is the electric flux because of this charge to this ring. So let's see how we can solve it. We know Gauss's law, right? We can use it here, but Gauss's law we use for closed surface. And here ring is not a closed surface. This for something. Yeah, ring. This is not a closed surface. How we can calculate them? Suppose there is a sphere, this kind of thing, and then charge is kept inside. Then how much flux will be passing through this closed surface? Definitely you will say according to Gauss's law, flux is what? Q enclosed by epsilon naught. So this is Q by epsilon naught. Now here in this question, we need to use solid angle concept, like for closed surface. At any point inside, solid angle formed is equal to how much? 4 pi. Okay. Now look at this question carefully. So why I wrote 4 pi? Because for 4 pi angle, this charge is giving how much flux? Q by epsilon naught. Now this is also area, certain area this is done. And if we are able to find what solid angle this area is uh, forming at this charge point, then we can calculate flux because of this Q charge, so this area. Because just now I have shown you, according to Gauss's law, flux through closed surface is Q by epsilon naught. And I said you, if surface is closed, then at any point inside, solid angle getting formed is 4 pi. So for angle 4 pi, flux will be Q by epsilon naught in this case. So now, if somehow we are able to calculate how much solid angle is getting formed by this area of ring, then we can calculate flux to it. So let's find out that. So formula for that is, here you can calculate like this, 2 pi 1 minus cos theta. This is the formula. Please remember it. So 2 pi, what is the theta here? Theta is this angle. Okay. So 1 minus cos theta. This is root 3r, this is r. This will become root 3r ka square, that is 3r square plus r square. So this is equal to 2r. So cos theta is equal to how much? Root 3r by 2r. So this is 2 pi by 2, 2 minus root 3. So this is equal to pi 2 minus, this is the solid angle getting formed. Now use the unitary method. Like for 4 pi Q by epsilon naught is the flux. For unit, it will be how much? 1 upon 4 pi Q by epsilon naught. So for this much angle, how much angle? Pi 2 minus root 3. How much flux will pass? So this is equal to pi into 2 minus root 3 Q by yes, Q by 4 pi epsilon naught. So pi will get cancelled. Answer will be Q by 4 epsilon naught 2 minus root 3. So correct answer is B. Okay. Sure. In the figure given, there are 3 charges placed at a separation A. The magnitude of electric field at a point P at a perpendicular distance R on a line joining this charges E. So we have to calculate electric field at point P. Condition given is R is far greater than A. Okay. So if we do it here, see, can we like by looking at this diagram, first thing that must have come into your head is dipole, for sure. Okay. But there is a problem because this minus Q plus Q will form one dipole. But what about this minus Q getting left alone? Then we can do something here. See, what I'm going to do is, here already there is minus Q. Here already there is plus Q. And here there is already minus Q. What I'm going to do, I'm going to keep at middle point 1 plus Q charge and 1 minus Q charge. There will be no effect on the net charge because in total I'm keeping there what? 0 charge, because I'm keeping both plus Q and minus Q. Why I'm doing this? Because if I do something like this minus Q and this plus Q will become one dipole. This plus Q and this minus Q will become one dipole, and then this minus Q will remain there alone. Okay. So now let's replace it like this. So now the system of charge will look like, here there is a minus Q charge, and then there is a dipole here, minus Q plus Q in this direction, and then there is dipole here in this direction. Okay. And we have to calculate electric field at point P such that R is far greater than A. Now, electric field at point P, because of this dipole, will be in which direction? Will be opposite to the direction of dipole. So it will be in this direction. And electric field at this point, because of this dipole, again, will be opposite to the direction of dipole because it's the equatorial position, right? That's the formula. And here it will be opposite, means in this direction. And since both dipole have same magnitude, Q into A, right? Their dipole moment is different, and also this P point is equidistant from the both dipole. It means what? It means these electric field are opposite in direction and also their magnitude is same. So 0, 0. So at point P, because of these two dipole, electric field will be what? 0. So because of minus Q, electric field will be here, will be something here, right? And what will be that value? So that you easily now calculate. Okay. So it will be KQ by R square because of point charge at a distance R. So correct option should be B. Now, a spherical cavity of radius r by 2 is made in a sphere of mass m. The acceleration due to gravity at a point A on imaginary surface of cavity is shown in the figure. So we have to calculate acceleration due to gravity at this point when there is a cavity inside. So if you look at carefully, this point is on the surface of bigger sphere and also on the surface of cavity. So for cavity, how we calculate field? So gravitational field at point P, say okay, at point A it is given, will be equal to gravitational field because of whole sphere minus gravitational field because of cavity. Okay? And here if you remember the formula in the case of a sphere, if a sphere is of mass m, then it, gravitational field at its surface is equal to nothing but gm by r square. So gravitational field because of a sphere has a mass of what? It has a mass of m. So gm by r. Now this cavity region, this will have mass of how much? This will have mass of how much? Its radius is how much? R by 2. Let's calculate its mass. Let's say in this region, density is rho. Mass density is rho. So mass of the cavity will be equal to rho into 4 by volume 4 by 3 by r cube by 8. And 1 by 8 into rho into 4 by 3 pi r cube. Now 4 by 3 pi r cube is the volume of whole sphere. Rho is the density. So this is capital M, mass of whole sphere. So mass of cavity is m by 8. This is your mass of cavity. Okay? Mass of cavity. So mass of cavity is m by 8. G m by 8 r. इसके लिए ये डिस्टेंस कितना होगा r by 2. So r by 2 का स्क्वायर करोगे आप r square into 4. So this will become this. ठीक है? So if we calculate it, how much value we are going to get? Gm by 2r का square. ठीक है? So correct answer will be again easy question. Now, if the two resistors of resistances R1 and R2 are connected in parallel, percentage error in equivalent resistance. क्या कैसे निकालोगे? So if there are two resistors R1 and R2 and if they are connected in parallel, then their R equivalent will be what? It will be like you can calculate like this: 1 by R equivalent equal to 1 by R1 plus 1 by R2. If you will solve it, R equivalent will look like R1 R2 by R1 plus R2. So I can write it like this. Okay? R1 R2 by R1 plus R2. And if you remember the law of calculating this, what is that called? Percentage error or relative error. Suppose there is some physical quantity P and it is A1, A2 by C2. A1, A2 by C2. So relative error in P is written as what? Delta A1 by A1 plus delta A2 by A2 plus delta C2 by C2. This is how we will write it. Okay. Similarly, we can apply this thing here. There are A1 is R1, A2 is R2, and C2 is R1 plus R2. So if we do that here, delta R1 by R1 plus delta R2 by R2 plus delta R1 plus R2 divided by R1 plus. तो डेल्टा R1 plus R2 कहने का मतलब एरर इन R1 और एरर इन R2. So इसको आप और कैसे लिख सकते हो? डेल्टा R1 by R1, डेल्टा R2 by R2 plus delta R1 plus delta R2 divided by R1 plus R2. If you will put the value, you will get the answer. Okay? Nothing much is required. So here 0.5 by क्या लिखोगे आप? 4. R1 is 4. Second is what? 0.5 by 60. ठीक है? And delta R1 plus delta R2 कितना हो जाएगा? 1. R1 plus R2 कितना होगा? 20. ठीक है? So you can solve it and then you will get the, sorry, this is your delta R equivalent by R. Okay. Now, if you want me to solve it, then what else needs to be done? तो यहाँ पे delta R equivalent को आप क्या लिखोगे? R equivalent into all this thing. So ये सारे को अगर आप ऐड करोगे ना कितना जाएगा? Let's make the denominator same. तो इसको मैं 4 से मल्टीप्लाई कर रही हूँ 5 और since this is 20, this is 20. कितना होगा? ये हो जाएगा 20 into 0.5. This will become 10 and this is 2.5 and this is 4. So 10 plus 4, 14, 14 plus 2.5, 16.25. So 16.25 divided by 80. R equivalent आप निकाल लो. R equivalent कितना होगा? R1 into R2. So R1 कितना है? 4 है, 8 है, 16 divided by 20. So this is equal to 16 by 5. So 16 by 5 into 16.25 by 80. So this is this. Okay, but what we needed to calculate? Percentage error ना, so R equivalent को multiply करने की जरूरत नहीं है. So this is 16.25 we are getting, and so are we getting wrong? Let's check the calculation. So percentage error, not absolute error, we have to calculate. So let's do it. Let's correct it here. Okay. I thought like we have to calculate absolute error, but not. So this is this. This will be this. So percentage error, if we have to do, then this will become this into 100, right? So this is 16.25 by 80 into 100. If we go on to solve it, it will come closer to 20 point something, right? So correct answer should be what? D. So D will be your correct answer. Let's move on to the next question. So the container is fully filled with a fluid of density rho. If it is accelerated horizontally with an acceleration g, find the net force applied by fluid on the left wall of area A. How to solve this question? Suppose this tank is in rest. So if it is in rest and it is filled with water, what will be the force acting on this wall? What will be the force? Force will be because of pressure of the liquid. So pressure of the liquid will be, pressure due to liquid will be different at this point, at this point, at this point, because how we write the pressure. Like if pressure at the top is P0, then pressure at any height H below will be equal to how much? Will be equal to P0 plus rho G H. So this G is what? Acceleration due to gravity. So if acceleration due to gravity is taken into account, that is, if that acceleration is taken into account, then pressure acting on the wall can be calculated like what? Like pressure is not constant at any one point. So what we need to do is, suppose pressure due to like pressure getting exerted by liquid because of gravitational effect, I would say. So at this point, if I calculate, this is this area, small area I'm taking, and this is at what height below? Suppose this is at X height below. So pressure at this area, for this area will be how much? Pressure will be equal to, since nothing is getting talked about the top point pressure, so I'm taking that as 0. So here pressure at this point will become equal to how much? Rho G X. So this is the pressure. And if we talk about This is the pressure. If we talk about force, then force will be equal to what? Because pressure is equal to what? Force per unit area. Done. So if we have to calculate force, we will multiply pressure with area. What will be the area of this strip? Area of this strip will be equal to its this length is x, and this is equal to how much? H, because this is the cube of side h. So rho g x into this width is how much? This width is taken as dx, suppose. So it will become dx into h. So how much force, small force I am calculating for this strip. So this will be equal to rho g h x dx. So how much? Rho g h x square by 2. X will vary from here x is 0 and here x will become equal to h. So x is varying from 0 to h, and here you will write rho g h cube by 2. So it can be written as rho g h ka square will be area of this left wall, h ka square. So h ko square ko I am writing as a, and then this will be by. So this is the force acting on left wall because of gravity. Okay, because this pressure is arising because of acceleration due to gravity. Now this cube is not in rest. There is another acceleration, and another acceleration is in which direction? That is in this direction. So if we look at the direction of acceleration, this is this, and this wall, if we talk about this wall, then this wall is at a constant distance from this end, right? So if we talk about pressure acting or pressure at any point, this, because of this acceleration, then pressure here will be equal to how much? Its distance from this end is how much? It is equal to h. So pressure is equal to how much? Rho a h. Rho a h. Rho into acceleration into its height. Done. So height हम कैसे लेते हैं? जैसे in this case, we were calculating pressure because of acceleration due to gravity. Acceleration due to gravity is in downward direction. So along this direction, we were taking the height. And here acceleration is in this direction. So along this direction, we will calculate the height of this end from this, right? So this is P equal to rho A H. Okay. And here acceleration is also, value is also G. So pressure acting will be rho G H. Now you just see all point of this left wall is at equal distance h. So pressure at all point is same, that is rho g h. Constant pressure. So force on the left wall because of this acceleration will be equal to how much? Rho g h into area. So this is this. Now what will be the total force acting on the left wall? So it will be because of two pressure getting arisen here. One because of acceleration due to gravity, and another because of the container acceleration, right? So total force, if you calculate F total, it will be equal to how much? Rho g a h by 2 plus rho g h. This will be equal to 3 rho g a h by 2. So correct answer will be B. I hope it is clear. Now let's calculate this question. Let's solve this. The figure given below shows a spring block system placed on a smooth horizontal surface. A time varying force F equal to 5T is getting applied on a mass of 2 kg. It was found that after 10 seconds, after T equal to 15 seconds, velocity of 3 kg block is equal to how much? 30 meter per second. So the velocity of 2 kg block will be what? So velocity of 2 kg block will be. So if we consider this whole as a system, because if you don't solve it from the frame or from the, if you don't solve it by taking 3 kg and 2 kg mass as a system, then this spring will come into account. And if a spring comes into account, then question will become very difficult. Because then you need to write potential energy, kinetic energy, and blah blah. So it will become tedious, and it may require more uh, known variables to solve this question. But if we solve it taking 3 kg and 2 kg a system, in that case, what we can see is this is a system of 5 kg, and on the system of 5 kg, how much force is acting? This much force is acting. And if we know the velocity of this system after 10 seconds, we can easily calculate what? Velocity of 2 kg by using center of mass concept. Okay? So if you look at this 5 kg system, after 10 seconds, what will be its velocity of this 5 kg? So force acting is 5t. If you break it, this is ma equal to 5t, and this is m, and this is acceleration. Acceleration can be written as v dv by dt. Sorry, this can be written as m dv by dt, and this is equal to 5t. M is equal to system ka mass is 5 kg. I'm calculating for the system. So this m will get cancelled with 5, and dv of the system, change in velocity of system, is dv. Initial velocity of system is 0 because initially if you put t equal to 0, force is 0, it is at rest. Okay. So this 0 to v, 0 to t equal to how much second? 10 seconds. So this is equal to how much? V is equal to t square by 2 के लिए 0 से 10 रखोगे. So this is 50. यानी कि velocity of center of mass of this system is how much? 50 meter per second. Now use the formula. Formula is what? VCM equal to M2 M1 V1 plus M2 V2 divided by M1 plus M2. VCM is 50. M1, let's say M1 is 3 kg. So 3 into how much velocity is given? 30 plus M2 is how much? 2 V2. We don't know. Divided by 5. So this will become equal to how much? This is your 2 V2, and this is equal to 250 minus 90, and this will be equal to how much? 200. So this is 160, and V2 will become equal to 80 meter per second. So correct answer will be what? It will be. Now let's move on to the next question. So let's read the question. Two wires of same material is same, are hanging as shown in the figure. Breaking stress is equal for both the wires. So breaking stress meaning force per unit area such that this force is breaking the wire is same for both. Okay. So if M2 increases, the upper wire will break first. So if M2 increases, let's for some time assume that these two wires have same area of cross section. Okay. If we go with that assumption, in that case, if M2 is increasing, or let's say, let's calculate just the tension in these two wires, then we'll be able to see which will break first. So if I talk of first wire, then from first wire, two masses are hanging, M1 and M2. Done. So for first wire, tension will be equal to, for first wire, tension will be equal to T1 will be equal to M1 plus M2 G. So T1 equal to M1 plus M2 G. And in second, for second mass, or for second wire, I would say second wire, how much mass is hanged from the second wire? M2. Only M2 is pulling it downward, and for the first wire, both M1 and M2 is pulling it downward. That is why I've written it here like this. So in second wire, tension will be equal to M2 G. So if their area of cross section is same, then definitely if M2 is increasing, in that case, there will be more chance that first wire will break. But if area of cross section is not same, then we cannot compare, right? So if mass M2 increases, upper wire will break first. That will be true only when area of cross section of both the wire used here is same. That is not given in the question. So we cannot say anything. Reason, breaking load of two wires of same material can be different. Breaking load can be different even if breaking stress is same. Because if area of cross section is different, then this breaking load, that is force, will vary. So definitely reason is correct, assertion is false. So D will be the correct answer. Now, an electric sphere of charge 10 microcoulomb is placed at the origin. So it is placed at the origin. How much charge it has? 10 microcoulomb. Now, what we are doing, we are taking 2 points here, 2 points A and B, and A coordinate of A is given as root 2, and coordinate of B point is given as 2, 0. I'm just taking things outside the sphere. We'll take it inside also, like whatever you feel like. So if you see carefully, point A is at what distance and point B is at what distance? Point B is at a distance of 2 and point A, x coordinate is root 2, y coordinate is root 2. So this distance r will be equal to x square plus y square ka root under. So this is 2 plus 2 ka root, that is 2. So this distance is also same. So potential at A will be equal to kq by r. And potential at B equal to kq by, again, let's say this is r dash. And here r equal to r dash. Right? Q is also same because for the same sphere we are calculating. So potential at this point is same. So difference will be what? 0. So VA minus VB is equal to what? It is equal to 0. Now let's calculate this. An infinitely long solid cylinder of radius r has a uniform volume charge density ρ. It has a spherical cavity of radius r by 2, as shown in the figure. The magnitude of electric field at point P, which is at a distance how much? 2r from the axis of cylinder. So here, what will be the magnitude of electric field? So electric field because of cylinder minus electric field because of cavity. This will be the approach, right? Electric field because of cylinder at any outside point will be equal to how much? So since this is an infinitely long cylinder, let's say, okay, so we have to calculate electric field at point P. So if you calculate electric field at point P because of cylinder, how you can do it? You must have done it also, like if you have not field rate that magnetic field wala case, then in NCRT also, this thing is done for magnetic field. But let's do it here. Chalo, मैं explain करती हूँ. So suppose for cylinder we are calculating electric field at point P. So we can use Gauss's law here. So let's take Gaussian surface. Gaussian surface here for point P will be what? A cylinder only. So I am taking a cylinder of length L, suppose, and of area of cross section how much? 2r. Because at 2r distance we have to, sorry, of base radius 2r. Okay, so this is this. Now, if we use Gauss's law, then electric field will be outward like this. So it is this. If we are going to do E dot ds, area vector normal to the surface for this, ठीक है, चलो step by step जाना पड़ेगा यहाँ पे. जैसे if you look at cylinder, it will have two surface areas. One is curved and another is these two. So for this, area vector is in this direction, and for this, area vector is in this direction, and electric field is in this direction, like this, like this. So for this surface, flux will become 0 because area vector and electric field is perpendicular to each other. So flux for these two base areas is 0. There will be only flux through the curved surface, and that will be equal to E into 2 pi. एरिया ले लो इसका, रेडियस ले लो 2 पाई, RL होता है ना 2 पाई 2r into L. E dot ds हमने किया, थीटा तो 0 है, so cos 0 1 हो गया. This is equal to Q enclosed. Now what is the charge enclosed in this Gaussian surface? So that will be basically charge enclosed in this length of cylinder, right? So charge enclosed in this length of cylinder will be equal to how much? Area of cylinder, pi r square L. Be careful here. We will take radius of this original cylinder because charge is only contained inside that. We cannot take here 2r. Okay, for calculation of volume. So pi r square L into. So here you write pi r square rho L divided by Q enclosed by epsilon. So L will get cancelled. Pi will get cancelled. And how much value of electric field you are going to get? So value of electric field will be rho r by 4 epsilon. So this thing we got. This thing we got as equal to rho r by 3 epsilon naught minus. Now electric field because of cavity, how you will calculate? So this cavity is what? This is a sphere now. For this sphere, this point P is outside. So electric field because of cavity will be nothing but kq by 2r ka square. Now the question is, what is Q? Q is charge inside the cavity. Means that reason is taken out, but before it was taken out, or whatever is taken out has some charge, right? So that charge value will be how much? Q will be equal to 4 by 3 pi. इसका radius कितना है? R by 2. So R cube by 8 into 2. Okay? So this is this. Let's write it properly. 1 upon 4 pi epsilon naught into 4 by 3 pi R cube by 8 into rho into 4r का square. ठीक है? Now let's cut the things. Pi cancel होगा, and then this 4 will get cancelled, and what else is remaining here? Sorry, this is 4 here. Sorry. So what thing is remaining here? R square से एक r cancel हो जाएगा. So this is rho r by 24 into, or you can say 4 into 20. Yeah. Sure. So here we can write it as 4 into 8 into 3, that is 24. So this is rho r by 4 into 24. So rho r by 4 epsilon naught को यहाँ पे epsilon naught भी होगा, common ले लो. So what will remain? This will become 23 by 24. So now you can write the answer. K value will be equal to nothing but 16. This is 24 into 4, 96. So 16 into 6 will be 90. So K value will be equal to, correct answer should be. Okay. Now this is a very easy question. Ratio of moment of inertia of a square plate about an axis 1 to axis 2. So before understanding this question, let's say I have a rectangular lamina like this here. This is the mobile you can see. Okay. So if I'm taking an axis perpendicular to this, passing through its center, then moment of inertia will be equal to what? Let's say that is I. So I is equal to m a square plus b square by 12, where a and b is its side. This is a and this is b. Okay. Done it? So this I is along which axis? Along this axis. Now if I'm taking this axis, which axis I'm taking now? चलो एक axis समझ गए ना? For mobile phone only I'm doing this thing. So now axis I'm taking is this. Done. Or let's say कि A and B is equal here. Let's go with the question only. So question के ही साथ जाते हैं. Let's say here A is equal to B. So let's draw a rectangle. Sorry, a square plate. So now I'm taking another axis, that is this. That is in the plane of plate. Okay? And this is like this. So we can use here parallel axis or perpendicular axis theorem. We can say that I is equal to, let's say this is IY, and then let's draw the x-axis IX. So this will be equal to IY plus IX. And you already know that this plate is symmetrical along y and x-axis. You can call this as x-axis, this as y-axis, or you can say that y-axis is dividing plate into equal part, and also x is dividing it into two equal parts, such that their mass distribution is same from the same around the axis, right? So here we can say Iy is equal to Ix. So I can write here I is equal to 2Ix. I can write, okay? Now let's do another thing that is done here. अब मैं क्या लेने वाली हूँ? Let's say one axis I'm taking as this, and I'm calling it Ix dash. Okay? So another is this, and this is I'm calling as Iy dash. So again, perpendicular axis theorem we can use here. X dash, Y dash perpendicular to each other. I, that is perpendicular to both of this. So I can be written as Ix dash plus Iy dash. So I again can be written as 2Ix dash. If you look at equation 1 and equation 2, you can clearly say that Ix is equal to Ix dash. So similarly, this was your Ix and this is your Ix. So these two will be what? Equal. Okay. So the ratio of moment of inertia of a square plate about axis 1 to axis 2 is what? Same. Okay. Sure. Now let's do this question. A point charge Q 9 microcoulomb is placed at a distance CR from a conducting sphere of radius R. So there is a conductor. Let's understand this question. Okay, then solution will get easier. So this is a conducting sphere and there is a charge plus Q kept here. What will happen? Since this is a conductor, this is a positive charge. It will attract negative free charge here and positive charge will get accumulated here. You know, an electric field line will look like this. And again, it will go on like this. So this something like this is going to happen because of presence of plus Q charge in the vicinity of this conducting sphere. Okay. So charge is going to get induced. Done. And if we have to calculate what? Here in this question, what we have to calculate? Okay, let's read the question first. A point charge Q is placed at a distance 3r from a conducting sphere of radius r. So because of this is happening now. If the switch S is closed, so S को हमने close कर दिया. Charge flowing through the switch. तो जब ये switch open था, उस वक्त क्या होगा? उस वक्त ये होगा कि इस स्फीयर पे के इनसाइड पॉइंट, कोई भी एक इनसाइड पॉइंट ले लो, सपोज कर लो मैंने ये पॉइंट लिया. So at this point, because of plus Q, there will be certain potential. Because of plus Q, there will be certain potential. Because of induced charge, there will be no potential because net induced charge is 0. On one surface, negative, another surface, positive, such that total induced charge is 0. So at any inside point, potential is because of plus Q charge, not because of induced charge. Done. The moment we will switch the close the switch, what will happen? Again, before closing the switch, let me tell you one thing also. We already have studied that if there is a conducting sphere, then potential at any inside point remains what? Is constant, and that is equal to what? That is equal to potential on the surface. Okay, that also we know. Now let's close the surface. So we have closed it. Once we will close it, what will happen? Potential of the surface will become 0 because this is directly connected to Earth. So its surface potential is 0. It means potential at any inside point is becoming what? 0. Done. So if potential at any inside point is becoming 0, इसका क्या मतलब है? इसका मतलब ये है कि at inside point there was potential because of plus Q charge, and because of connection switch closing, potential is becoming 0. It means to counterbalance this positive potential at inside point, some negative charge must be flowing through this switch to the surface of this sphere. And that negative charge should be producing the same potential as that of plus Q at the inside. So for one inside point, distance is clearly given, that is 3r. Okay. So let's say potential at center will be because of plus Q charge कितना होगा? KQ by 3r. And because of charge traveling, it will be equal to how much? Suppose q charge is traveling, kq by r. These two should be equal. है ना? So let's say k into q is given now, that is 9. And this is 3r. And this k, capital Q, we don't know, this is r. So, sorry, this r will get cancelled, and this is 3. So q equal to 3, and as I said, this will be minus charge. So this is equal to minus 3 micro. This will be your correct answer. Okay. Now let's move on to the next. Now let us look at this question. Densities of two solid sphere A and B of the radii are, so their radii are equal. So let's say this is A, and let's say this is what? B. And both have the same radius, but what is different? Their densities are not constant, that is varying with R. And for A, that density is given as what? K small r by capital R. And for B, what it is written? Density of B is written as, this is also function of a small r, that is radial vector, like this. Done. And we have to calculate the ratio of their moment of inertia. So if density were constant, we can easily write the moment of inertia of these two spheres, that is 2 by 5 mr square. Then because these two are solid sphere, but since here density is not constant, this is a variable mass system, we need to calculate its moment of inertia through the process. Done. So what is the moment of inertia formula for a point mass that is at a distance r from the axis of rotation? So moment of inertia formula is I is equal to mr square. So for calculating moment of inertia of a sphere, you already know that in case of solid sphere, like whenever you are calculating moment of inertia for continuous mass distribution, then we need to select the element. And here, this is a solid sphere. We can see that solid sphere is made of many hollow spheres of different radii up to radius r, which is r is the radius of this solid sphere. Then, so our element will be what? Our element will be hollow sphere. Now, first step is to find out the element. Second step is to know the moment of inertia of the element. So here our element is what? Element is hollow sphere. And hollow sphere ka moment of inertia around center, around axis passing through its center is what? Moment of inertia for this is 2 by 3 m r square, where m is the mass of that hollow sphere, r is the radius of that hollow sphere. Once you're done with the element selection, once you know the moment of inertia of element, just calculate that moment of inertia of the element, like putting the value of m and everything, and then integrate it to calculate the moment of inertia of this solid sphere. So I will do that for you. Just see here, I'm going to do that for A. So A ke liye, I'm going to select element kya hai hamara? Hollow sphere. So I will take any hollow sphere of radius r. Okay, whose thickness is something, whose thickness is dr, suppose. So since mass is distributed in the volume, our element should also have some volume. That is why I'm saying I'm taking hollow sphere of width dr. So this element will have how much volume? It will have a volume of 4 pi r square dr. What will be its mass? Mass will be density into volume, that is constant को बाहर ले लेती हूँ, ठीक है? 4 pi k so by r cube dr. This will be our dm. Now what will be the di? Moment of inertia of this small element. Moment of inertia of this small element will be 2 by 3 m, that is dm here. So that is 4 pi k by r into r cube dr. So 2 by 3 m r square. So again एक r का square यहाँ रखोगे and then dr. So what value we are going to get? 8 pi k by 3 r, and this is how much? This is r pi dr. So if we have to calculate the whole moment of inertia, we will do the integration. And same thing we are going to do for the B. So again, B के लिए भी DM can be written as what? 4 pi k by, यहाँ पे r का पावर कितना दिया हुआ है? R 5 है, so constant में ऐसा जाएगा. And here r का पावर 5 है, तो here you will write r का पावर 5 dr. What will be the moment of inertia? Small moment of inertia. So into r square आप करोगे 2 by 3 m dm r square. So 8 pi k by 3 r5 into r7 r square into r5, तो r7 आएगा dr. ठीक है. If I have taken everything correctly, then this is your 4 pi r square. Okay, one thing I missed here. This will become r to the power 7. ठीक है. And this will become your r to the power. Done. So same thing you need to repeat for A and B, and then you need to calculate DI. So if you are calculating I for both A and B, what value you are going to get? Constant is what? 8 pi k by 3 is same in both the things. So मैं यहाँ पे लिख रही हूँ I A का value is how much? 8 pi k divided by 3r into this will become r6 by 6. And what will be IB? IB will be 8 pi k by 3 r5 into how much? This is r10 by, this is your how much? 10. Okay. So this will come like this. If you are going to take the ratio of IB by IA, definitely something by 10. So that is 6 by 10. So N will be equal to what? 6. So simple hai, you just need to calculate moment of inertia over here. Okay. Now let's look at the next question. A block of mass 2 kg is kept at the origin and is having velocity. Velocity is given 4√5 meter per second in the positive x direction. The only force on it is conservative and its potential energy is defined as U equal to minus x cube plus 6x square plus 50. Now its velocity when force acting on it is 0. So first we need to calculate when force will become 0. How we can calculate force? From potential energy we can calculate force because we know that force is equal to minus du by dx. So do the same thing, minus इसको differentiate करो with respect to x, so that will come as minus 3x square plus 12x. ठीक है. So this is force is equal to 12, sorry, this is equal to 3x square minus 12x. Okay, and this is 0 when x is equal to 4. So at x equal to 4, force is 0. So we have to calculate velocity when displacement is how much? 4 unit. Done. How we can do that now? So if acceleration is given, acceleration can be written as v dv by dx. Done. And acceleration can be calculated here since force is known. Force is what? Force is nothing but mass into acceleration. So acceleration is nothing but 3x square minus 12x. 3x square minus 12x divided by how much? Mass, that is 2 kg. And this is equal to v dv by dx. Now write the same variable on the same side. So this will become how much? 2v dv is equal to 3x square minus 12x dx. We have to calculate velocity. Initial velocity is 4√5 when x is equal to 0. And when x is equal to 4, we have to calculate the velocity. So this will become 2v square by 2. So 2v square by 2, 4√5 se v. And this is equal to how much? 3x cube by 3 minus 12x square by 2, 0 se 4. So if you are going to calculate it here, v square minus 80. And this is equal to how much? 64 minus, this is going to be how much? This is 6 now, 6 into 16. So that is 96. Done है. So v square is equal to 96 minus 64 करोगे कितना जाएगा? 32. So 80 minus 30, and that is equal to 48. So b square is equal to 48. B will be equal to how much? If b square was 49, in that case, b will be 7 meter per second. So near about b is here 7 meter per second. So we can say answer is 7. Now the last question of your paper. A body is projected horizontally from the top of a tall tower with a velocity of 30 meter per second. So let's say this is the tall tower of height h, and from here a ball is getting thrown horizontally, right? With speed 30 meter per second. So ball is being thrown like this. So it will fall like this. Then because under effect of gravity, it will gain vertical velocity. And since there is no talk about air resistance, we will neglect it and we will say that there is no force acting in the horizontal direction, and hence horizontal velocity will remain constant throughout, right? So what we have to calculate here, it said that at time t1, its horizontal and vertical component of velocities are equal. So at time t1, v horizontal is equal to v vertical. And right now I said you that horizontal velocity is not going to change. So that will remain 30 always. And v vertical, it will gain vertical velocity. Initial vertical velocity is what? Initial vertical velocity is 0. Final vertical velocity will be what? At the time when horizontal velocity is equal to vertical velocity. That is at time t1. So if we calculate final velocity, v equal to u plus at, v will be equal to gt1. Done. So here you will write g. G is 10. So t1 is how much? 3 seconds. 3 units, right? Now let's calculate t2. So what is said about t2? And at time t2, its horizontal and vertical displacements are equal. So horizontal displacement at time t2 kitna hoga? Since there is no acceleration in horizontal direction, horizontal displacement will be equal to horizontal velocity into time. Okay? And what will be the vertical displacement? Vertical displacement can be written as uyt plus half ayt square. So yt2 को क्या लिख सकते हैं? uy 0 initially half into 10 into t2 का square, right? So this is 5 t2 square. Since these two are equal, let's equate them. So 5 t2 square is equal to 30 t2. So t2 is equal to 6. t1 is 3, t2 is 6. So difference will be t2 minus t1 will be equal to 3 seconds. Done. So 3 will be your correct answer. I hope I have answered all your queries. I mean, I have taken up all the questions you were having doubt in. But even if you are having doubt in any other question, you can ask me during the class. Okay. Till then, bye-bye, take care and keep attending all the tests. Thank you.